Okay, as I've mentioned before, we're not just doing math for the sake of math. We're actually interested in developing tools to solve problems. So we're going to look at a couple of examples, and in this segment we're going to look at a perimeter problem. I'm just going to walk through the problem-solving process with this example. So we will be using actually a system of equations to solve this perimeter problem, and here's your problem. The length of a rectangular yard, and I'm going to write out the whole thing. So as you read it, the picture of a rectangle is hopefully coming to your head, is 10 meters more. And again, the word more is a clue that we might have some addition involved than the width. The perimeter is 60 meters. Is 60 meters, M for meters. Find the length and the width. Now, we want to make sure we answer the right question. So one very handy little trick that you can use is simply to circle the statement that has the word find in it. And that way, when you're at the end of the problem, you can look back and say, did I really answer the right question? So our first major step in the problem-solving process is to list what we know. And I always like to draw a picture with that because whenever you're working with a problem that involves shapes, a picture is going to help you tremendously. So we're going to list what we know, and in this case, it'll come in the form of a picture. So what do we know? Well, we have a rectangular yard. So we've got a rectangle. It has some length L. That's a rectangle. And go ahead and use variables. We're going to have to define some variables or some unknowns. Use variables that go with the words. L goes with length and W goes with width. Now, we know that the length is the width plus 10. That's what that 10 meters more than indicates. So we can say that L equals W plus 10. And we also know that the perimeter is 60 meters. That's the information we were given. Our next task, then, is to model this situation with equations. And we're really almost there. What we have to remember is that the perimeter is the distance around. So we have one length and a width, another length, and another width. So our perimeter is 2L plus 2W. And we established when we listed out what we knew that that the length is W plus 10. We also need to get rid of this letter P. 2L plus 2W is equal to 60. So let me rewrite this so that the system's a little neater and tidier. Our system of equations is 2L plus 2W equals 60, and L equals W plus 10. Well, this system is already set up in a way that suggests let's solve by substitution. And step 3 is to solve. So we'll just substitute for L the W plus 10 in the first equation. So we'll have 2 times W plus 10 plus 2W is equal to 60. This is an old familiar type of equation. We have one variable. We'll use our distributive property. 2W plus 20 plus 2W is equal to 60. Combining, we have 4W plus 20 is equal to 60. And now we're going to solve. We'll just subtract 20, and we have 4W is equal to 40. We'll divide by 4, and we find that W is equal to 10. Now, we need to substitute back. We know that the length is W plus 10, so we'll just put in 10 for that, and we get that the length is 20 meters. W is 10, L is 20. We need to ask ourselves, did we answer the question? Well, you look back and you see that you circled, I'll put A and S for answer and 2 question marks for the question. Did we answer the question? The question was find length and width. So yes, we answered it. Are they reasonable answers? Well, 10 meters and 20 meters is pretty reasonable for a little yard. And if I check the perimeter, 20 plus 20 plus 10 plus 10 does indeed equal 60. So yes, these are reasonable answers. Many of you probably can solve this problem just by doing a guess and check method. And that's wonderful, and it's a great skill to have. The skill you want to work on developing is drawing the picture, laying out the equations, and solving the equations at this point.